RoboDK webinar will start in a few seconds. Note that if you are experiencing any connection or image quality issues, this webinar is also live streamed on YouTube Live. The link to access this streaming will be available in the chat section. Hey, what's up guys? Jeremy here from RoboDK. I'm super happy to host this live webinar today. It's great to be able to connect with you guys. These are challenging times for everyone, and I feel it's a good thing to concentrate on what we can do instead of what we can't do. That being said, you guys are already, a few hundreds robot users watching right now, so feel free to use the chat here to connect with one another, maybe discuss the subjects I'm bringing. It's a great opportunity for everyone, I believe. I'll myself be happy to connect with you guys after the presentation, obviously, either here in the chat or on our forum or on LinkedIn. Before jumping to the main subject, here's a few things you need to know about this webinar. First, the agenda will go a bit like this. I'll start by presenting some of the RoboDK's features. Then I'll do a technical demo on a few of these features, and finally I will answer your questions. Talking about questions, feel free to write them down in the chat, so you can use the Ask Question option, bottom right corner of your screen. You can also make the questions private if you feel the need to do so. There's an option for that on the side. Another thing, if you are experiencing connection issues, disconnection, bad image quality, or other, we are also streaming live on YouTube. We've put the link at the top of the chat section. Okay, one last thing. I created some poll or some questions for this webinar. My goal is to try to know you guys better and, if possible, improve the future webinars according to your answer. I would therefore really appreciate if you can answer them. So here's an easy one to get warmed up. Is it the first time you guys watch a RoboDK live webinar? So you can answer just right here. Easy question to start. Anyway, let's jump right into it. Today's topic is CAD to PAT. So for those who may not know, CAD stands for Computer Aided Design. So CAD to PAT is a pretty broad topic, but we could summarize by saying it's a simple way to go from the 3D model of your part to a robot program that can be executed on your robot controller. This is in part why the founder of RoboDK decided to create that software, to give robot users an affordable tool to easily create what would normally be challenging robot programs. And obviously being able to do so starting from the 3D model of the part you are working on. So CAD to PAT is not one single feature inside RoboDK. In fact, there's many features that could be included in this package. The first one being the Teach on Surface feature. Then you have the Curve Follow project, the machining project, and finally all of our plugins for the CAD and CAM softwares. So if we go take a quick overview, of these features. So the Teach Target on Surface, or Teach on Surface, this is by far the easiest method for a RoboDK beginners. So you simply import the part either as a step file, IGES, STL, or in a few other file format. Then you activate the feature and you simply click wherever you want on the part to create targets that will touch the surface of the part. I'm not going to give you too much details right now on this feature because the live demo I will do in a few minutes will pretty much cover it all. So, and the small video you can see just right there is pretty much the demo we will do together in a few minutes. Okay, the next feature is the curve follow project. This is a tiny bit more complex, but it's so powerful once you get a good grasp of this feature. So quickly, this feature, as the name implies, will help you follow a curve on the part you are working on. So in the example just beside me, just right here, I've used this feature to create a dispensing program. The curve follow project is equipped with a lot of tools to help you in your project. So you can tools to help you manage the orientation of the tool along the path, automatically avoid singularities and joint limits, activate outputs at certain points of the program, like here for the glue applicator, for example, and much more. There's different ways to generate the path itself. You can extract it directly from the 3D model imported in RoboDK. You can import it from a list of points as a text file or a CSV file. You could have created that list of points manually, or let's say with a custom algorithm that you created. And you can also import it using one of our CAD plugin. So this is a super strong combo, but I'll give you more details on that in a few moments. Okay, the next feature is the machining project. The machining project is very closely related to the curve follow project. The menus, the options, and all are pretty much the same. The only real difference is how the path is imported. In the case of a machining project, the path is imported from a CAM program or a machining program. So for example, if you have a CAM software and you created a milling project in it, you can generate your G-code-like file, so maybe an APT or NCI, for example, and drag and drop it to RoboDK to generate the machining project. Again, you can manage things like joint limits and singularities, but you can also manage tool change and spindle RPM if required. The specific example I'm showcasing here, the 3-axis milling, is part of a tutorial we released this week on our YouTube channel. So if you feel that you would like to take a look at it, feel free to do so after this webinar. This brings me to the last CAD to PAT feature of RoboDK. So our CAD and CAM plugins. Okay, so stay with me, guys. I'm almost done with the talking. Here, okay. So in total fairness, the plugins are not really feature, but more of a better way to import the path to RoboDK. So they pretty much create a combo between either the curve follow project and machining project and the CAD software you generally use. So plugins are small tools that we develop in some CAD and CAM software to improve the workflow from the designing software to RoboDK. So we already support quite a few software and we're constantly adding new ones, but here's a list of some of the ones we already have. So on the CAD side, you can find Autodesk Fusion 360 and Inventor, SolidWorks, Rhino 3D, and we are about to launch a new one in the near future. With this plugin, you can do many things. You can obviously import the part you designed in the software, but you can also import points and import curves. The nice thing about the curve importing the curve is the curves can either be the edges of your part, but they can also be 2D and 3D sketches. So this is great. Here's a small example on here's a small example of how it works. So if you have the part, you can select whatever feature you want to import, in this case an edge, but as I said before, you can be the part, points, or the curve. Then you import that to RoboDK. You can then manage the tool orientation, approach and retract movements, IO's activation, and other parameters. Then you generate the path and upload it directly on the robot controller to be executed just like this. This is a video I did earlier this year, so you can watch it back on YouTube if you want to see it more closely. And as I said, one of the great things about this feature is that considering that you can import 2D and 3D sketches, you can pretty much draw any path you want on the part in your CAD software and import it to RoboDK. In my opinion, that gives you a lot of flexibility to create some fancy robot trajectory. Okay, I'll just go back to the slide with the logos. We also have integration with some CAM software. Again, for those not familiar with the meaning of CAM, it stands for Computer Aided Manufacturing, pretty much machining software. The goal of the CAM plugins is to create a bridge between the machining software and RoboDK, a bridge that will automatically transfer the milling program to RoboDK, in fact. So at the moment, we support the manufacturing features of Fusion 360. We also support Mastercam and Mexsoft, and a few more that are not listed here. So if you go take a look at our online documentation, you can find the complete list. Keep in mind that you don't need to have these CAM software in order to create a robot machining program in RoboDK. Any CAM software would work here. These plugins simply gives you a faster and easier workflow. That's it. Okay, so that's pretty much round up what I needed to tell you about the different features. If you have any question on those, feel free to write them down in the chat. We will answer the questions at the end of the presentation. Okay, so one small poll question before we switch to the demo. Which one of these features have you already used, if you ever used one of those? Okay, so let's jump to RoboDK. So here's our first station. It's a pretty simple one using a Fanuc M20 AI, a Mitre scan from Creaform, and a part that some of you may recognize from the basic guide series. So if you didn't have the chance to take a look at the basic guide series, I would highly recommend you to do so. It's available on our YouTube channel. That will give you a lot of basic tricks on how to use RoboDK properly. So here's the task for this one. So let's say that we want to inspect this simple part. One way of doing that will be to manually create robot targets or robot targets, right? That you come here, you reorient the tool, you say okay, just like that, somewhere like this, and I'm just gonna create a first target, then I'm gonna go forward, then create another one like that, and then so on and so forth. But that won't be super fast and that won't be super precise either. So there's a better way to do that. So let's bring the robot back to home. Okay, so if you go in the main menu and you click program, and let's say teach target on surface, by default, these two options will be activated, so add target and normal. So we'll stick to them for the moment. You'll see as soon as I'm gonna bring my mouse on the surface of the surface of the object, some kind of ghost robot and ghost tool will appear with a small TCP at the end, and as you can see, it's always try to keep itself normal to the surface here. So if I just like click, let's say right there, it created a target. I can click right here. It created another target. You can see those targets created in the station tree like that. I can come here, create those ones like that. And as you can see, in less time than it took me to create 2 targets the manual way, I already created 8 of those, and I'm sure that they are touching the surface and that they are normal to that surface. So okay, so that's great. Now we can create a robot program with those, so I can select them all. let's just rename them first. So let's say part inspection. Okay, so it renamed the targets and it gave them a number. And if I right click, I can select create program, and it will create a program for me. I can right click rename or press F2 to simply give it a name, inspect part, let's say. And once I have this, I can right click on it and click generate robot program to generate the real robot program that I need to send to my robot controller. So just like that here, I have the 8 moves that I need to do here, and I have all the different position right here in the registry. So this is an AS file. This is meant to be uploaded on a FANUC robot. So if you've selected another robot, it will create a different file depending on the robot controller and the robot controller. In this case here, your robot controller for the FANUC may or may not accept the LS file directly. You may need to compile it to TP, so there's a way to do so. Once you created your targets like that, you can modify the position of them either by holding Alt, and just like using the different arrows to modify their position or the orientation. So this is an option to modify the position. Or let's say if I go to the second position like that, I can also right click on it and click option, or press F3. So just like that, I'll have this little window that will appear, and starting from here I can directly modify the values right here. So let's say that I wanted to have it directly on the edge here. I know that this part measures 600 millimeters, so if I go for 600, the new target is directly on the edge right there. So those are the two ways to modify the targets that were created by this feature. Okay, I'm just gonna bring that to the side. So this is fairly easy. So now let's go for a bit more complex example. So here I still have the same robot, the same scanner, and now I have some car transmission, the casing of a car transmission in fact. And let's say that I need to inspect this side here. So if I go for program, teach target on surface, and I bring the robot here, you can see that, yeah, I'm touching the surface, but the problem is that the orientation of the tool is not right, not even close. So it gives me a strange configuration, and the robot is pretty much like destroying itself. So what I can do is use my left and right arrow, or up and down, same result, to rotate around the Z axis of the TCP, just like that, and create my new targets. I can create another one here, another one there. As you may have noticed, if you take a look at the on the other side, the blue wheel here, if I'm using my arrows, the wheel here will rotate. So this is how you manage those. The red wheel will manage the rotation around the tool x-axis, and the green one the tool y-axis. So I can create another point here. Again, it will always be normal to the surface I selected. So just like that, I created all the targets I needed to inspect this part here. But let's say that I do not want to be normal to the surface here. Let's say that I just want to keep the same distance all the time, but that I want to be like in the same orientation as this one for the whole inspection. So let's delete all of them. Let's go back to the first one. I go program, teach target on surface. Here, instead of using normal, let's use constant. So now it will just stay constant to this orientation like that. Even if I click on this surface here. The targets are really on the surface, but the orientation is the same as I defined here. Again, I click done like that, and now I have my program. So I can select them all, create robot program, and then I have my program just like this. If I delete all of those and I bring back the robot to its home position, so right click home, and I use the same process, so teach target on surface with the constant. Right now, as you can see, it's mimicking the orientation we have right now, so it's not necessarily what we want. So if you wanted just a small trick on this one, you just go with the normal for the first one, you adjust the rotation like that, you create your first target, you escape from this feature, this will create your first position, and you know the robot is now at this place here, and you can go teach target on surface again. Now you use the constant method, you create your targets, and then and then you have the result, the expected result. Okay. Next thing, let's say that we want to inspect those 4 holes right there. So if I go here and teach target on surface, let's say normal, and I try to like have a target right there. First of all, it's difficult because it's trying to snap on the inner surfaces of the holes. But even if I'm trying to be like right in the middle, it's hard to make sure that you're really in the middle and you are not keeping a constant distance with the outside surface, but rather with the inside surface, which is not necessarily what you want. So one of the options you can use to avoid that problem is here, the snap on arc center. So if you select that and you come just close to the external arc, you can press, you can click, and it will create a target right in the middle, just like that. Again, like that. And let's say here I still have another one to do, just like that here. So in like that, just in a few seconds, I was able to create a robot program to inspect all those holes we have here. So that's great, I think. Okay. Let's say that now we want to, I'm just going to bring the robot back to home. Let's say that we want to inspect this line here and this line there. So if I go back to teach target on surface, I'm going to remove the snap on arc center, and I'm going to use now the snap on curve midpoint and edges. This one, as soon as you'll bring your robot close to an edge, again, you'll see the blue line appearing. And if you're close enough and you press, it will create a target right at the end of this surface. Same here for the middle point of this surface, so of this line, sorry, and here with the end. And let's create the end here, the middle point like that, and the end point just like that. Now this one didn't work because I selected the top surface, so right now the z-axis is pointing toward the bottom. So if I just click here instead, that would work like this. So again, I can click done, select them all, and create a robot program. And now, oops, yeah, I forgot to rotate my tool before creating the target. So right now I'm not able to go upward as I'm hitting a singularity. So what I should have done is like, again, teach target on surface, come here, and then rotate 180 degrees, just like that, create my first target, create my second one, my third one, fourth one, fifth one, and then last one. As you say, don't need to be super precise for it to snap on the end. So if I just create the robot program, now I have the robot program that I required. Okay. There's another option that we can take a look at is the automatically extract surface corners. So by definition in RoboDK, surface corners are points on where 3 or more surfaces meet each other. So let's say here again, I can, let's say, just snap on the corner. Oops, I didn't activate it. So I can just snap on the corner. Don't need to be super close for it to work. So I could do that here. I could do that there. So for the moment, it gives me the same result. But let's say here that I want to have these here. So even if it's a curve, that's pretty much just a bunch of polygons. So here we have another corner. I can press minus a few times if I want to see things in a smaller way and create more targets. Just like that. This one is not right, as I selected this surface instead of selecting this one. I'm gonna go back to this here, that, like that. Let's say like this, that, and last one here. So just like that, I created 14 different targets. I can click done, select them all, and then right click, create a program. Yeah, so that works. Perfect. One last little thing that I want to show you here. Here you can see, let's say that we have those two lines here. They're not super close to one another, but still, let's say that I want to, okay. So if I come here, it select the upper line, and I don't need to go very far, so that it select the one underneath it. I can press plus a few times so that you can see the normals in a better way. So I don't have a lot of room to manage here. And especially if you have smaller parts, that will become even more complicated. But if you go in Tools, Options, you will see in Display the Pick Curve Sensibilities. So if, let's say, I bring that to 1 and click OK, now I need to be way closer to the line for it to snap on it. It can be a good or a bad thing depending on the situation. Like I said, with smaller parts, it's a better thing to have those quite small here. I'm going to bring that back to its original value of 10. Click OK, and now we're done for this example. Let's jump to the other one. So again, same robot, same scanner. Now we add the Q bar from Creaform here in Quebec for the inspection. So this is an interesting setup where I'm just going to close that here, where the turntable is synchronized with the robot. So this way both can move at the same time in a synchronous way. And you have here the C track from Creaform again. This is here to keep track of where the Mitrascan is. So when they inspect that, they don't need to take into account the precision of the robot. They simply take into account the position of this with respect to the Mitrascan, and then all the parts that are scanned, or all the surfaces that are scanned afterwards, can relate to this position. So if I double click here the program, the robot, sorry, you can see that, like I said, here everything is synchronized, so I can move here the turntable. So the only thing I want to do here is fairly quickly create a program to inspect all the holes we have right there. So to do that, again, let's say teach target on surface. I'm going to go for the snap on arc center. I can start from here, go there, 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 and then let's rotate a bit the turntable. Let's start from the bottom here. Just like that. Oops, this one is not right. Just gonna go back to the last one, as it takes the orientation of the position of the robot right now to create the last one. Okay, interesting thing here. As you can see, you don't need to have a full circle. Just you have just a small portion of the arc that will create the target as required. So I could go there, there, let's say here, 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 And then let's rotate that again. There's not so many holes on this side, just a few ones like that. And then let's just do the last side of it. So just like that. Just like that. Here, this one, this one, this one, and this one. I think we missed one here. And now we're done. So if I go back to a better point of view, I can click done, and I can create a robot program for that. And now it will inspect all the holes I have on the part, just like this. Okay, so that's great. I don't think this one is available. So this is great. So okay, so this is one of the other interesting thing you can do with the teach target on surface, but there's more to it. So here's the last example here. So this is a machining setup that I created, like I said, for a tutorials that I released this week. So here, if you remember from the getting started guide, there's a few things. If you want to create, let's say, a custom tools, there's a few things you can do. So first of all, you import the part, and then you need to set up where the exact TCP position is. So you can either double click on it and then enter the right values right there, or you can eyeball it by just clicking holding Alt and Shift, and then bringing it at the right position. But this is not super precise and not super convenient. So now we have a better way of doing that. Go to Program, and then again, Teach Target on Surface. Here you have the Add tool. So the Add tool will pretty much just create a new TCP. So let's say that I'm selecting here by selecting the Snap on Arc surface. I can come here, create the tool like this. From there, I have two options. As you can see here, it created a tool snap. So I can just use that for my program. Or if I really want to have this value for the spindle TCP, I can open it by double clicking on it. I'm just going to go down here. And then I'm going to copy, here the button copy, and then here paste. And now if I just like hide this one, you can see that the TCP of the spindle is still at the right position, like that. So this was quite easy and fast, I would say. But sometimes things are not that simple. So let's say here in this example here, I have a drill bit at the end of the spindle. So this cannot simply be snapped to the arc surface because there is no real arc at the end here. So what I can do is, again, Program, Teach Target on Surface, Add Tool, and this time I'm gonna activate the Snap Cylinder axis. So what I'll do is I'll just like select this axis right here, just like that. And this way it will keep things along the axis of this cylinder. So here I created that. So because without it, I wouldn't be able to do so because of the drill bit helicoidal pattern. And again, I can double click here on the created snap tool. I can copy the value here, open the little spindle, and then paste the value. So both match together. If I delete the tool snap, now I have the TCP at the right position. So this was the first thing. Second thing is here. Let's say that I have my machining setup and I want to have the origin of the setup right in the corner here. So one thing I can do is Teach Target on Surface, and this time I'm going to use the Add Reference. I'm going to unselect everything here, and I'm going to simply go right at the corner here. If I was here, I could use my arrows to change the orientation of the reference frame that was created, and I can click OK. And now if I want to, I'm gonna click done. And now if I want everything here to go inside this reference frame, I can select the setup and the wall panel, right click, change support, and then frame snap. This way they won't move and they will simply change like what is the parent-child relationship between the parts and the reference frame. And now that everything is inside the frame snap, I can like move it and everything will follow together. So yeah, so that's it for that. Okay, so one last example. I'm gonna go back to the second example I showed you. And this time I won't use the teach target on surface. I'm gonna give you like a little small demo about the curve follow project. So if you go on utilities and curve follow project, it will create this this window here. Let's say that I want to follow the line I was trying to follow before. So it took some time to go and select the different points and all. But here, if I go on select curve, and if the auto extract curves is activated, I can come close to the curve here, and as soon as you see the blue line, you can select, and it will select that curve. Now, as you can see, it will go from point 1 to point 2. Let's say that I want it to go the other way, so I can click switch sense. I can go auto select next curve. Oh no, I cannot because I didn't extract it, so I need to go clear near here. Can click on it, right click, switch sense, and if I go closer, I can let's say select this other part here. As you can see, I'm not able to select this section here really. This is because of the other options I showed you before. So tool, display, and then here pick curve sensibility. So if I bring that down to 1, click OK, now you can select the whole lines, and let's do the same here. So now I have this path here. So if I click done, by default, the curve follow project will create a line following this path. So if I update and simply simulate like this, so that's interesting. But as you can see here, the orientation of the tool is quite strange. So what I can do is I'm just going to need to showcase where the TCP is. I'm going to rotate the tool like this. I say, okay, this is kind of the orientation that I need. And I'm going to simply click on the teach button right here and then update and simulate again. And it will follow the orientation I just teached it. So again, I can, like I said before, right click, generate robot program. And then after a few seconds, the window will appear with the generated program for the finite controller with all the points to reach, just like that. And so all the move commands and all the points to reach below. Okay, so that's pretty much what I wanted to show you guys today. I hope you think it was helpful. Before switching to the question period, I'm just gonna play a small video that I pre-recorded, just the time for me to get a sip of water and take a look at the questions. So I'll be back in a few, 2 minutes maximum. Okay. Okay, guys. So I'm simply here in a... Okay, guys. So now it's time to... oops. Sorry. Just gonna place that here. I'm just gonna start sharing on this one again. Screen to share. Oh yeah. So yeah, guys, I'm gonna answer a few questions that you had. First one being, is there a way to convert G-code to APT in RoboDK? No, there's no way to convert G-code to APT in RoboDK, but some G-code can be accepted. So what I would recommend you is just to try drag and dropping your G-code into RoboDK after creating a station. So just add a robot, a tool, a reference frame. Try drag and dropping your G-code to RoboDK, and see if it works. If it doesn't, so if it tells you that it's not a known file format, try to use your CAM software to use another post processor, with your CAM software, and therefore being able to generate the program you are another file format that would be acceptable for RoboDK. So, for example, APT, TAP, NCI, ACL, and a few others. So other questions. Sorry, I'm gonna switch that here so that I can see what's going on with the questions. Sorry for that. Another one. How do I tell the robot distance between the product and the robot? So this is a good question. So I'm going to reopen the let's say inspection transmission project. So to know the exact distance between the tool and the robot, if you say right-click the robot and click visible TCP, so available TCP for tool center point. So the tool center point will help you, let's say, define the distance between the flange and the TCP or tool center point. So if you double click the tool here, you will see the exact position of this TCP with respect to the flange. But let's say that you really want to have, let's say, a specific distance between this part here and the TCP right there. So there's a little way to do that. So let's say I'm gonna go again, program, teach target on surface. I'm gonna go add tool. I'm gonna snap, let's say here. Oops. Gonna snap on, oh, I cannot snap here for some strange reason. I'm gonna go just teach target on surface right there. Oh, don't know why it's lagging a lot right now. Okay, so I created a tool snap just like this on the tip of the tool. So what I can do now is add another TCP. So let's say right-click the robot, add TCP. It will create a TCP by default that will be at exactly 00200, like that. But let's say that I want, from this point that I touched, I want to be exactly, let's say, 300 millimeters along the z-axis of this one. So I can do two things. So either I double-click the tool snap I created, and instead here of giving the distance between tool center point with respect to, and let's say now it's the robot flange, I could go here and say apply relative move and enter the exact distance that I want to have. So this would be an option. Or the other option, so the problem with this option is that as soon as you apply this movement, you won't be able to go back to where you were priorly. Another option would be to simply open the tool you just created at 200 along Z from the flange. And here, instead of center point with respect to the robot flange, you can go for center point with respect to the tool snap we created. You can click here and say the reset to put it back to its original position. And then I can enter the 300 here. And now this TCP is exactly at 300 millimeters from the point where I snapped on the surface. So I hope this answers your question. Let's see what else, what other question we have. Just gonna go back here. Not there. Don't know where my questions are now. Oh, here. Okay. Do you have any tips on dispensing to be considered during the offline simulation? Yeah. So Cristiano Lima asked, do you have any tips for dispensing to be considered during the offline simulation? So let's say distance between the part and the product. I do not have any tips to give you. That will really depend on how you you set up what kind of product, what kind of height layer you want to have, what kind of thickness you want to have. So there's a lot of things that will depend on this one. Here, someone asked me, can you upload the video on YouTube, please? Yeah, I know that there was some problem today. I'm really sorry for that. We were trying a new technique. It worked just fine on YouTube, but let's say that one webinar jam, there was some, let's say, mismatch, or let's say little problems. As usual, the webinar will be available directly on YouTube around 12:15. In the webinar playlist, so you can check it out. So if I go back, let's say just to YouTube here, or let's say I'm gonna go on our YouTube channel directly. In the playlist, you will see all the webinars we did. So we had 2 webinars right there. So I will add the other one like in half an hour or something, just a time for me to upload it to the platform. Other question we had, okay, so that's pretty much it. So there was a private question about the Kawasaki driver, that being answered. Okay, so someone asked me about how does the post-processor works. First thing first, I would recommend you to go take a look at our online documentation. So in our online documentation, you will see the in post-processor, you will see how to select, modify, and so on the different post-processor. So this is where you can, let's say, learn the basics of post-processor. But if you want to create a whole new post-processor, I would recommend you to start from one we already have. So if you go in Programs, you can click Add and Edit Post-Processor. Now you have the list of all the post-processors. So let's say if I select the one we were using right now for this robot, it will this window will appear with after a few seconds if it wants. Okay, let come in. So this is the post processor. So pretty much it's a Python file that will be executed to translate what RoboDK creates as a program here into the robot like specific syntax or language, if I can say. So if I just go Control F and say look for move L, so you have here in this situation, or the move J, let's say the move J is quite easy. So if we face a move J in RoboDK, the post processor for the FANUC robot in this case will convert that into J, and then the line with the position, and then join speed, and then the CTN value, which is pretty much the rounding. So do you want to have a continuous or fine movement between the points? Just like that. Same here for the move L. So it will create L with the value of the point again. So target with the values of the target here, target ID, sorry, the speed and the count. This one is not necessarily the easiest one because FANUC has a, let's say, uses register to add to manage the points. But if I go, let's say, and I go for one that is a bit easier in my sense, so let's say ABB for rapid. If you come here and let's say Control F again for move L. A move L here is fairly simple. So when we face a move L, we will add move L with the target with the as the first variable, the target values, speed data, zone data, tool data, and work object data. So yeah, so my recommendation would be to start from an existing post processor and work your way from that. Okay, next question. If the curve is closed, is there a way to specify the start and ending point of the closed curve? That depends. If the curve is just like a circle, there's no real way to decide where to start. But let's say here, if I go and delete those two here, if I go program, no, utility, sorry, curve follow project, and I'm going to extract, let's say, one of these here. So select curve, extract this one. So now I have, oops, don't need to see all this. So now I have the curve, but it's impossible to know where it starts and where it ends for the moment. But now that I did that, it extracted the curve. Oh no, yeah, it extracted the curve. So if I go just on top of it, you can see the curve. You can right click on it and you can split the curve. Like you can split it, let's say, in half where there's corners, or split at the end and just give a number of millimeters where to split. So let's say if I split that in half, I now have this half and this half here. I could, let's say, do it again. Let's say split curve, split in half, and then split in half. And then you could select, like, let's say, you can come here again, utilities, curve follow project, select curve. I don't want to auto extract this time, so I can say, okay, I want to start from here. Oops, my bad on this one. So I want to start from here, and then I want to go there and there and there. But honestly, the best way to do that, if you really want to decide where you want to start, would be to use one of our CAD plugin. So with the CAD plugin, you could literally just draw the path as an arc instead of drawing it as a circle. So if you draw an arc, you will be able to decide where the points start and where it ends. Okay. Is there a way to display the targets created by the curve follow project? There's a way. It's a bit hidden. But there's a way to do that. So if I just like update this path here, I have the program created here. If I right click and let's say, oops, not display path, my bad, show instructions, it will showcase all the move that needs to be done like that. Don't worry too much about the orientation here. I didn't manage this one. If I bring back the robot to its home position like that, now I can select, let's say, all these points here. Right click, click select targets. That will create a bunch of targets, as you can see them right here, and you have them manually here, so you could modify those values individually afterwards. Now obviously it's not super cool to see that because I have the robot in front of me, but yeah, so now you have all the targets right there. Okay, do I have any other questions here? No, perfect. Okay, and just let's see if we have questions on YouTube. Okay, there's no audio. Oh, sorry, I'm so sorry. I forgot to start the audio on Webinar Jam. That's a bummer. I'm sorry for that. That's my mistake. Yeah, I should have think about it. Oh dang. So yeah, you could have listened to the answer on the other, and yeah, my colleague told me that I was not listening. Okay. And if there's any question here, if you want to add a robot to RoboDK, it's fairly easy. You go to Tools, Utilities, Model, Mechanisms, and Robot, and you can select the 6-axis industrial robot, just like that, right here. And you just need to insert the different parts. Now it's just like using transmission everywhere because this is the only part I have in the station. But generally speaking, you can add like the base, joint 1, joint 2, joint 3, joint 4, joint 5, joint 6. And then you just enter the some of the DH table parameters, you can easily find those from the datasheet of the robot. Okay. Okay, I think that it's... Do you have a plugin available for Solid Edge? I'm not supposed to talk about that, I think, but it could be maybe the next one we will release. I don't know. Maybe yes, maybe no. That's your choice to figure out that. But I would say that if you stay tuned to our YouTube channel and our newsletter and all, you have a good chance of maybe finding a plugin for Solid Edge in a short time. Is there any other questions that I missed? Okay. I think that's pretty much it on this side. Like I said, I'm super sorry for the few problems we had. Is there a way to export a bunch of targets to a text file? So I don't think that it's possible to export targets, but it's possible to export lines though. So if I just like delete that here and delete all this here, delete this program here, right click and move home. When you come closer to the line, you can right click on it and you can export the curve. It will create a CSV file with the curve. So if I save that here, it should be on my desktop somewhere, just like that. And now you have the XYZ IGK vector of the curve exported. So you can have the values right here. Do you have an example for a cobot welding? Not really, because there's not really a difference between cobot welding and robot welding in general. The only real difference is that usually industrial robot have included features that will let you manage weave and let's say every parameters of the weld included in the robot controller. This is not always the case. I'm not aware that it's the case with cobot, to be honest. So therefore, you would have to create them. These parameters manually to create your little weave if needed. But if you just need to follow a line, you will simply follow a line as usual. I have a if I go here, I have a YouTube tutorial on kind of this concept just right here. So basic welding. So if you take a look at this one, you should have kind of a few information how to do robot welding there. Okay, I think that pretty much sums up all the questions. I'm super happy that you guys were here. Thanks a lot for that. Sorry for the little technical difficulties. That was kind of out of my control. This is why we are trying to broadcast on both platforms so that you guys can switch to YouTube if there's any problems with our webinar platform. So we'll try to fix that before the next video. The next webinar. In the next webinar, if everything goes according to plan, I should be presenting more information about the curve follow project, how to import curves and stuff like that, how to manage the parameters, tool orientation, joint limits, singularity avoidance, approach retract, IO activations, and all those nice stuff. So just stay tuned. I'm going to try to manage the problems on my side and give you a better experience next time. So I'm very sorry for the technical difficulty, as I said. Have a great day, guys.